The investment casting process. Mold making. Wax pattern injection molds are machined from 6061 aluminum utilizing CAD/CAM customer-provided files. This reduces lead time and increases accuracy of the final part. Wax pattern injection. Wax patterns are produced by injecting liquid or paste wax into the mold at 120 degrees. Gating or metal feed systems are built into the mold and are integral with the wax pattern. Some molds open automatically, others manually, by unscrewing several bolts. Parts with undercuts or holes may either have a water-soluble core or ceramic core placed into the mold prior to injection. There can be more than one cavity or part in a mold. Size, volume, and cores may allow for only one cavity per mold. Wax patterns. A number of wax patterns are injected to make up a production lot. One wax pattern per part required. The wax patterns are carefully inspected for defects, as any imperfection in the wax pattern will appear on the metal part. Multiple wax patterns are assembled on a frame, or tree, as it is more commonly referred to. A standard tree is 14 inches high and 12 inches wide. The number of parts on a tree is a factor in the cost of a part. The more parts on the tree reduces the piece part cost. Ceramic shell, prime slurry. The wax assemblies are coated with a fine ceramic liquid called slurry. Application of sand. The wax assembly is then covered with a fine sand while the slurry is still wet. Great care must be taken at this stage to make sure the entire part has been covered completely with sand. The first 2 coats of fine sand predicate the finish of the casting. Typically, a 125 RMS or better can be expected in the investment casting process. Drying time. The wax assembly with a fresh coat of ceramic must dry before moving on to the next dip. Typically, the parts will be left to dry for about 24 hours. Shell, slurry, and sand. Subsequent layers of slurry and sand are applied to build a permeable ceramic shell. Additional drying time. After each layer of slurry and sand, the shell is allowed to dry completely to make a strong ceramic shell. A total of 4 to 6 layers are applied to cover the wax pattern. Completed ceramic shells. Finished ceramic shells are now ready for the next step in the process, which is to remove the wax from the inside of the shell. Autoclave dewax. Ceramic shells are processed in a steam autoclave to melt the wax out. Shells are quickly heated so as not to crack the coating. Wax drains out of the ceramic sprue cup at the bottom of the mold. High temperature burnout. Dewaxed shells are put into an oven that is heated up to 1600 to 1800 degrees Fahrenheit to burn out residual wax and cure the ceramic. Fired ceramic molds. Fired ceramic molds are now ready to be preheated prior to pouring the molten metal. Shells will be heated to 2000 degrees Fahrenheit to reduce thermoshock to the mold when pouring the metal into the mold. Metal casting. Metal is melted in crucible-lined furnaces. The preparation of molten metal is critical to the casting quality. Once the metal has been melted and degassed, it is ready to pour. The metal is poured by hand into the ceramic mold. Alloys are cast at varying temperatures. Non-ferrous, 1350 to 2600 degrees Fahrenheit. Ferrous, 2800 to 3200 degrees Fahrenheit. Post-cast ceramic shell. The metal casting has now taken the shape of the wax pattern and assembly. After the assembly cools to room temperature, the shell will be removed. This is done by either knocking off the shell by tapping on the runner system or vibrating the metal mold. Shell removal. Remaining ceramic is removed from the cast metal assemblies using high-pressure water jet guns. Cut-off. Saws are used to remove the gates and risers. These may be remelted and used for other castings. A metal slug is checked with a spectrometer prior to each heat pouring for exact chemistry of alloy. Gate grinding. Gates are further removed by rough grinding them on a sand belter. Finishing of the casting. Any deburring or hand finishing can be done at this time. Heat treating. Subsequent processing usually includes heat treating to improve the physical properties of the alloy cast. Sandblast finish. In most cases, a sandblast finish is used to blend the surfaces and present a clean, uniform finish. Ceramic or glass beads are typically used. Steel shot can contaminate the surface of aluminum. This gives the appearance of rust on the parts. Therefore, steel shot should not be used with non-ferrous alloys. Fluorescent penetrate inspection. Fluorescent penetrate inspection may be required when castings must meet strict mil specs. This non-destructive testing process will detect surface flaws that may not be visible to the eye. X-ray. Further NDT may also be required. Therefore, X-ray may be used to detect flaws below the surface of the casting. Test bars. Mechanical properties are determined by pulling a test bar on a tensile testing machine. The machine measures the amount of force that is required to break the test bar. Tensile strength, yield strength, elongation. Test bars are cast with each heat, so traceability is available for each cast part. Spectrometer. A spectrometer is used to check the chemistry of every casting lot to determine that all parts produced meet the customer's specifications. Dimensional inspection. Dimensional characteristics can be measured 100% for compliance by CMM and hand measuring tools. Secondary machining. Many foundries have capabilities dedicated to providing their customers with precision machined castings. The investment casting experience. Here you can see that the final cast part is identical to the injection pattern in every detail. The investment casting process is the same for both ferrous and non-ferrous alloys. Please send Palmer Associates your casting challenge. Let the experts at Palmer Associates evaluate your casting requirements. We can take your next project from rapid prototype through low, medium, or high volume production. Preceding video courtesy of Alcumet Inc. Alcumet is a precision investment casting foundry that is AS 9100 ISO 9001 certified and NADCAP compliant for NDT. You may now have a better understanding of the investment casting process and the services that Alcumet provides. Please click on www.castingreps.com Investment Casting for design and process information. Please use the alloy charts to best select an alloy to comply with your application need. Please contact Palmer Associates for assistance with your casting project. PDF and 3D files of your design can be sent to www.castingreps.com or call toll-free 888-494-0414.